Hello everyone. Today I want to show you an SWR meter, SW102D. The SW102 model actually has three versions, but this time we'll be talking about the D version. So, what is an SWR meter? The purpose of an SWR meter is to make sure the frequency transmitted by the radio is accurately interpreted and transmitted through the antenna. Essentially, the frequency will go through the meter and then to the antenna. If the frequency is reflected by the antenna, altering the frequency, we will see it in the meter. In this chart, we can see the efficiency of each set of SWR values. From 1 to 1.5, the antenna matches the transmission device output almost perfectly. But the higher it goes, the worse the antenna can transmit the output. If your radio has a PL259 connector, it will fit perfectly into the SO239 socket. But if the meter uses the Type N connector, you will need an adapter like this one right here. For this demonstration, I'll use the meter with the SO239 connector. To turn on the meter, hold the red power button for a few seconds. Once it is turned on, let's have a look at the display. At the top right corner, you will find the forward power. Right under, you'll find the transport efficiency for the transmission. Below, you'll find a big display of the SWR value. The closer the value is to 1, the better. At the bottom right, you'll find the reverse power. Moving to the left, you'll find another forward power at the bottom. Above it, there's a line of text indicating whether the radio is in DMR or analog mode. Right above, you'll find the input frequency. This will show the frequency that is being transmitted by the radio. At the top left corner, you'll find the battery level. Next to it, you'll see what the meter is being powered by. In this case, the B stands for battery. The clock next to it will show you the time of operation. And right below, we have the version number of the meter. Now, let's take a look at the meter itself. With the socket on the left, you will see a label that says TX. This socket is for connecting transmission devices. With the socket on the right, you will see a label that says ANT. This socket is for connecting antennas. Let me connect both of these to the meter. Once everything is securely connected, we can hit the transmission. On the screen, we can see the forward power to be around 12 watts, and the SWR being 1.13. 1.13 is pretty close to 1, so we can say that the quality of this antenna is almost perfect. On a side note, if you want to flip the display, hold down the yellow button and you will find the screen flipped upside down. Just another useful function for better usability. Anyway, looking at our display again, we can find that the transmission is in DMR mode. Let's try it in analog mode. Switch to analog mode in your radio and hit transmission. We can see very quickly that the meter is showing the analog indicator. Now, besides being an SWR meter, this can also be used as a power meter. To accurately test for the transmission power, we'll need to use something called a dummy load. This dummy load is not included in the package and will need to be bought separately. Remove the antenna and install the dummy load to the antenna socket. Another thing, you can see that I'm using an antenna mount here. Using this meter, we can actually test to see if the mount is faulty. Let's give it a try. Hit transmission, and we can see a forward power of around 7.8 watt. Also, you will see that the SWR value is 1. A dummy load will pretty much always have an SWR of 1. We use it to almost pretend that it is a perfect antenna, which is why it will always have a value of 1 or slightly above that. Let's try it without using the antenna mount. Connect the dummy load directly to the meter and we can hit transmission. We can see that the forward power is around 7.8, similar to when we're using the antenna mount. So we can say that the antenna mount is not faulty. In addition, let's talk about how to measure the transmission power more accurately. Usually, when we're measuring the power, we use something called the center frequency. For VHF, we use 145 MHz, and for UHF, we use 430 MHz. And again, use a dummy load when you're measuring transmission power. Now, let's move on to the menu options of this meter. Press the blue button to enter the menu. The first option is to set how many minutes it takes for the screen to turn off by itself. Use the blue and yellow button to choose the value, and use the red button to cycle through the options. The second option is to set how many minutes it takes for the meter to turn off, from 1 minute to 9 minutes. The third option is for fine-tuning of the frequency input. Option number 4 to 7 are all fine-tuning options for the frequency input. You can do micro adjustments to both VHF and UHF frequency over or below 5 watts. The eighth option is for fine-tuning the DMR frequency input. Once everything is set to your liking, save it by holding the red button for a few seconds. When you release the button, 3 options will appear at the bottom of the screen. You can choose to resume setting, save and exit, or exit without saving. Thank you for watching.